We talk to companies who have DevOps people, and we ask them who runs the database, who's in charge of maintaining it. And it's whoever set up the database at their last job, draws the short straw, and they're responsible for setting up the database at the new job.
This is DevOps Paradox, episode number 193, Automatic AI-Powered Database Tuning using OtterTune. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. Victor, I'm an old school database person.
Okay.
How often did you actually have to get into doing database stuff when you were starting out?
Like hardcore database or?
Well, even just not necessarily hardcore, but just getting started writing SQL, doing those kinds of things.
I don't know, maybe 20-something years ago.
Okay.
Something like that. Actually, one of my jobs was to fine-tune other people's messes in databases. Long time ago.
And fine-tuning those things, that was always a really simple thing, right? You could get that done in 2 or 3 minutes and you could spend the rest of your day doing nothing.
Sometimes actually, often no, but sometimes you say, okay, this was so silly, kind of like it's so obviously silly that I'm going to fix it in 15 minutes and then I'm going to pretend for next 2 weeks that I'm working on it so that I can work on something else.
But in reality, that's not always how it worked out, especially when you saw select star, right? Select star that's one of the first things you always learn. And it's like, no, don't do that. Why are we talking about databases? Well, today we have on Dr. Andy Pavlo. How you doing, Andy?
Hey, thanks for having me.
Not the kind of doctor I can start complaining to, right?
No.
My back hurts type of, no.
We could, but it wouldn't help you any.
A database doctor.
You're saying database doctor, but legitimately, you have your doctorate, you have a PhD. We were joking about this before we started recording. You have indefinite tenure at Carnegie Mellon University. Now, if you're not in the United States, you probably haven't heard of Carnegie Mellon, but you've heard of the other 3 top computer science schools, and Carnegie Mellon is in the top 4. The other 3 being, Andy, help me remember.
It's MIT, Stanford, Berkeley, and Carnegie Mellon. Now, I will say, though, in the recent rankings that came out, we used to be in a 4-way tie with those schools. Carnegie Mellon would be at the top because of alphabetical sorting. But in the most recent U.S. News ranking, we went down 1. So MIT is the only one in first place. And then we're tied with Stanford, Berkeley, and Carnegie Mellon. So it's obviously not, nobody takes this stuff real seriously. But Carnegie Mellon is known for computer science.
I wasn't joking when I said I started back with databases. When I started working in programming in databases, I was doing multi-value and key-value stores back in the 80s and reading people like CJ Date and EF Cod. And everybody's saying, okay, who are those people? And back then, when you could actually go into a micro center and buy books, those were the books I was buying. Obviously, I had no life. So Andy is the CEO at OtterTune, which helps you automate some of the pain and suffering of optimizing databases, and specifically Postgres and MySQL, correct? Or MySQL based. Is that the proper way to say that?
The core algorithms right now support only Postgres and MySQL, but we've done deployments in Oracle in the past when it was a research project.
And there you've already sort of peeled back the layer. AI tuning. Okay, obviously coming out of academics, AI has always been sort of there. Let's rewind just a little bit. When we started out years ago doing index tuning and query tuning, it could take days. And then all of a sudden, one more row gets inserted into a table, and all that tuning you've done has been dropped on the floor. Was there a better way to do it 5, 10, 20 years ago?
I mean, specifically index tuning is an old problem. When the first relational databases, or actually the first papers from Ted Codd came out in the 1970s, people recognized early on that with the abstraction of the relational model and the actual physical data, that somebody was going to have to pick what the best index was for these tables. Because in SQL, it's a declarative language. You don't say how you actually want to run the query. You say, this is the answer I want. It's up to the database system to figure out the best way to run it. So obviously, someone has to figure out these are the indexes these queries are going to need. So one of the first papers actually goes back to like 1976 on how to automatically pick indexes. And it was actually written by my PhD advisor's advisor, wrote it in 76. And so people have been trying to solve this problem for a long time. And the algorithms have changed, certainly, as computing has gotten better. A lot of great work was done in the early 2000s at Microsoft and the AutoAdmin project. But in the last 10 years, we've definitely hit the new era where everyone's throwing machine learning and AI at this problem. And some of the results have actually been quite impressive.
So machine learning and AI, who really started introducing that? Was that Microsoft? I mean, obviously everybody's sort of doing it, but who sort of started taking that first step?
I would probably say it was definitely probably academia. There might have been some papers in Microsoft, specifically Microsoft Research, maybe late 2000s. Like there was a sprinkling of ML papers or ML for database papers around, but it's certainly not it didn't come top of mind. It's not the sort of the main thrust for a lot of research groups as it is today. I would say, I mean, from my own perspective, with OtterTune, we weren't looking at index tuning, and we didn't look at like query tuning and other things. Because I felt that there was already a lot of research done on those particular problems, but knob tuning was something that I felt that no one has really tried to address. Partly because the problem had not become as pronounced as it was, or didn't become as more significant as in the late 2000s, early 2010s, as it maybe was in the 1980s, because the number of knobs available for these databases was actually quite low. But over time, they'd add new features. It became harder and harder to tune these things. I wouldn't say, I can't think of any, like there's one paper that or this one research group was the one that got everyone to pay attention to using machine learning for database tuning and optimization. It sort of was a natural progression of us seeing how ML was making great strides in playing Go, playing chess, a bunch of other problems, and then it made sense to apply it to databases because it's a very challenging problem to tune databases.
Give us an example of one of the knobs.
So maybe it makes sense to first explain what I mean by knob. So they're sometimes called configuration parameters. Some systems call these system variables. The different database systems call them different things. But the basic idea is that these are a configuration control setting that the database system exposes to you as the end user or administrator to allow you to change the runtime behavior of the database system in different ways. So some knobs are things like directory paths, file names, port numbers. Right? These are things you wouldn't want to tune automatically. You need to set them up just for the system to run correctly. But then there's variables that control resource allocations, like how much memory you should use for the buffer pool, how much memory you should use when you build a hash table, doing a join. And then there's other knobs that control policies, like behavior when, how and when should you evict, data from the cache, or how aggressive it should be doing compaction or vacuuming, like in Postgres. So you want to tune the last two groups, not the first one, because if you change a port number and you can't connect to it, then the database is useless. So we have been looking at MySQL and Postgres. MySQL has probably about 500 knobs at this point. Postgres is maybe in the 400 range. But in the commercial systems like Oracle, using them as an example, I mean, they're in the probably almost 1,000 at this point, and that's the documented ones. Then there's the special secret ones that you're not supposed to tune with underscores. That's another couple thousand or so. And again, not all these knobs will affect performance, but enough of them do, and enough of them matter that like if you can tune them correctly for the workload that the application is trying to run, you can make a huge difference. The metaphor I like to use for this would be, you can think of a database system as like a generic car frame. You can put big tires on it and make a truck and haul stuff, or you can put a fast engine in it and make it race around the track real quickly. So the database system has these knobs where you can change its behavior in different ways for maybe workloads that are read heavy versus write heavy, or doing analytics or operational workloads. You can change the system and tailor it for exactly what the workload is going to try to do, and improve the efficiency, improve performance, and just reduce the cost of running your database system. when you look at something like MySQL has over 500 knobs, maybe less than 100 actually matter for performance, but there's still enough of them that it's beyond the capabilities where a human can reason about and try to tune. And certainly we see a lot of cases where companies and organizations aren't just running one database anymore, right? It's no longer you have this giant monolithic, mainframe box that everybody's connected to this single database instance. There's dozens and dozens of databases from these different microservices and other projects running in an organization, and you have to tune each one for the knobs for each one of them. And that's at that scale is just not something a human can possibly do.
To me, that sounds like a problem even before we reached ML and machine learning and all this stuff. Kind of sounds like exaggerating number of knobs. In a way, not that they're useless, but kind of as if it almost sounds as if vendors or people behind those databases are shifting the problem somewhere else, to the person in a way, right?
Sure, absolutely. Yeah, I mean, you're right. When a database engineer is building the system and they're adding a new feature, at some point you have to make a decision of how to do something. And you could put a pound defined or hard-coded value in there, but the problem is that's probably not good enough. It's probably the lowest common denominator. It wouldn't work well for a lot of different application scenarios. And so they just, to your point, they kick the can down the road, expose it as a knob, and assume that someone else is going to come along who's more knowledgeable about how the application wants to use the database, who'll be able to figure out how to set that correctly. But in the era that we're in now with the, for your guys' podcast focusing on DevOps, it's, the DevOps role has taken over what used to be a DBA role. I mean, certainly DBAs exist, and there's still a lot of work to be done with them. But a lot of organizations and companies, especially smaller ones, don't have full-time DBAs. They don't have people that know the ins and outs of these different database systems. And so what we often see, again, from a research perspective and at the startup, we talk to companies who have DevOps people, and we ask them who runs the database, who's in charge of maintaining it. And it's whoever set up the database at their last job draws the short straw, and they're responsible for setting up the database at the new job. But all they do is maybe read some blog articles, and that's it. They don't know the internals. They don't know what they're doing. This is why I think automation can help, right? ML can help.
That reminds me of full stack developers, right? The back and forth front end and a database, right? I never understood how somebody expected that to be realistic, unless we're talking about very low expectations in a way, right? How can a human understand front and back end and a database enough to actually really run it?
Yes, and I think databases are just, for me, they're fascinating. I've spent my career focused on them, so I'm obviously super biased in saying how great they are. And I teach courses at Carnegie Mellon that help people build new databases. So there's that. But they have so many different moving parts because not only do you have to worry about not losing your data or not having incorrect values or anomalies when you're running transactions and queries, they also have to try to run as fast as possible. And so for most people, it's a black box. I mean, even for me, I don't, there's corners of Postgres and MySQL. I just don't understand what they're actually doing. And it's not reasonable to expect anybody to know how to tune these things. And this is where, again, I think automation is the future.
When we take a look at either tuning one or the other, now I did want to ask one thing specifically around MySQL. It covers MySQL and Maria, or what's the big difference between those two? Because there was a big fight, they broke up.
Yes.
How does that come into play?
I mean, so I can talk from a research perspective. There's no difference from the algorithm standpoint, right? Like the machine learning models, at least in case in OtterTune, they don't know what a knob is. They don't know what an index is. Like there's nothing. It's not general purpose AI. It can discern what an index is. It just says it's just numbers, right? And so from the algorithm standpoint, it doesn't matter whether it's MySQL or MariaDB or Oracle or Postgres. It tries to optimize it based on the objective function. Like I want to make the queries run faster or reduce CPU utilization. The challenge we face in the commercial version of OtterTune is that it's actually interacting with the database system running in the cloud. And so we only support MySQL and Postgres right now because we're a startup. We want to focus on those markets, and it's they're large enough that we think it would benefit enough people. We could potentially support MariaDB. if it was running whatever their default engine is, I don't think it's InnoDB anymore, but it looks very similar. I don't know. There's a bunch of these other new engines that MariaDB has bought over the years. I think they bought Clustrix, they bought the column store, which I think is AffiniDB. I might be wrong about that, but they have different engines, and the front end is still MariaDB, but the knobs you would tune would be different for these different engines. We can support them. Again, it's from the algorithm standpoint, it's not hard to add a new database system, but it's interacting with the database system, interfacing with it, collecting the data, massaging it, and putting it in the form that we need. We find that to be the biggest challenge when deploying something like OtterTune.
How does it work in a nutshell? I mean, without going into, complicated details, AI or machine learning, all the story about databases. If I would now want to use it, do you train it on my data or it already comes half trained from other cases? How do you train it?
For this one, I'll specifically talk about OtterTune for knob tuning. I can talk about query tuning, and I can talk about the research stuff. This will be about OtterTune, like the commercial product. The original version of OtterTune at the university would actually try to use prior data from previous workloads to pre-train the models. And the idea would be you would look at the runtime metrics of the database system, pages read, pages written, locks held, wait times, and all that. That would be a representation of what the application was actually trying to do. So we didn't actually look at the queries, and we didn't look at the actual data. We just looked at these runtime telemetry that every database system maintains, and we'd use that to find other workloads that look similar to this new workload, and then we would have the training data already set up for that, and we could sort of bootstrap the models based on that. That worked in the research environment because we were dealing with a finite number of workloads that we had available to us and a finite number of hardware. When we deploy the commercial version, the challenge has been is that there's so many different instance sizes on Amazon, so you have to now account for hardware in your models. There's also provision IOPS, which is another parameter you can have on your hardware. So that's been a bit more challenging. So the current version is the current commercial version is less aggressive using training data from other databases, and it is primarily focused on your single database. But it still does a pretty good job of converging fairly quickly.
When we get our knobs figured out, or actually I should say when the AI gets the knobs figured out, what would that be like if I was trying to do it myself? I mean, you called it out. Back in my day, I tried to buy as many hard drives as small as possible, so I get as many spindles running as possible. Yes, spindles, not SSD, because this was before SSD. Then we had SSD come around. Then we had these multi-terabyte size machines show up to where I can get everything in memory. Forget about cache. It's actually in memory. How do we actually try to go about tuning databases in 2022 and beyond based on the hardware we're going? You just called it out. There are a wide range of hardware that can be running at any point in time. And I imagine, obviously, that tuning is going to be completely different based on instance sizes or storage.
But there's sort of two problems there. Like, how do you, assuming the hardware is fixed, how do you tune the knobs? We can talk about how to do that. And then there's also people ask us to do essentially capacity planning or provisioning for them to say, here's my database, here's my workload. What instance size should I be running on? Because they want to cut costs. We can't solve that second problem. We can't, in OtterTune, we can't actually tell you just yet what we think the right instance size is for you. We'll get there. We're just not there yet. And there's other problems I think are more important before you get there. On the knob tuning side, again, as I said, like it's, if you assume the hardware is fixed, then the models will eventually converge based on what the best ways to use the workload is. And I guess another good example would be the challenges. One of the things that has been challenging in transitioning from the university to the startup is, having stable workloads where you can say, you can have a baseline and say, am I making things better or not? And by fixing the hardware, that's one less variable you have to deal with. I would say the reason why we're not solving the provisioning problem just yet is because there's other low-hanging fruit or other important things you need to solve first before you get there. And specifically, it would be like query tuning and index tuning. And that's the major thing that we're adding to OtterTune in the commercial version that we didn't really touch in the academic version. And so I think those are important to if your queries are garbage, the query plans are, sequential scans nonstop, or you're wasting a bunch of IOPS maintaining indexes you're never going to need. then yeah, you can bump up your instance size, maybe get better performance, but you actually would do a lot better and either pay less or have better latency or better performance if you tune these other things. So we're focused on that.
Where should people start if they're trying to tune? Like going back to my old DBA days, because I was a DBA on both sides. By the way, DBA meant two different things. You were a database administrator or you were a database, what was the other A? I don't even remember anymore. See, I'm that old today. There were two DBAs. Well, like one that would write the stuff and one would manage everything. I handled both sides of the house. And we had to, on Friday afternoons, getting ready to go into a weekend, we were trying to figure out, okay, well, what we saw out throughout the week, performance was getting horrible. It was spiking at this certain time of day. We were able to capture some queries, but we weren't capturing some disk data, some CPU, but not a lot. I guess really we did have access to all these knobs even back then, but there was no good way to actually, I guess, keep track of them, I guess is what I'm going for. So how does OtterTune really keep track of those? I'm assuming you're polling all the time. I'm hoping you didn't install an agent into these databases.
This is one of the reasons when we forked it from the university and became a startup, we decided to specifically only target RDS running in Amazon because they standardize the API. They have standard API through CloudWatch, Performance Insights, and parameter groups to retrieve the runtime telemetry of the database system. We can retrieve and set the parameter, the knobs through Amazon. So that simplifies all of this. And so OtterTune keeps track. It polls every so often. I forget what the frequency is, but it's not obviously every second. But it polls every so often to see what the current knobs are for each database system. And we keep a history. Anytime we see a change, we basically keep a version history of that. And we can allow people to go back and say, this previous version of the knob setting was better, go back to that. Whereas Amazon doesn't support that kind of cataloging the history of things. Now, to your point about what do you actually have to install to make this work? If you come to OtterTune's website, you would give us permissions to retrieve this telemetry from AWS, and we can do some basic optimizations. But to get the full benefit, do all the query tuning, index tuning stuff, you would actually want to run an agent that you don't install it into the database system itself because Amazon doesn't let you do that. Amazon doesn't let you install arbitrary binaries or extensions to Postgres MySQL. So it'd be a Docker agent that someone would run in their network, and it's just a conduit that sends back data that connects to the database system. I will say one of the things that sort of the reason why we started with knob tuning with OtterTune, began back at the research project, was as an academic, it's often very hard to get access to real workloads, real data sets to run experiments. So when I was looking at what kind of auto tuning stuff could we look into, I decided to pick knobs because I thought, and this idea of just looking at the telemetry, because that information is benign, and a lot of companies, a lot of organizations don't mind sharing that because it's pages read, pages written. Nobody cares. We've done deployments at big European companies, and their InfoSec people looked at what we were sending back, and there was no GDPR issues, no privacy issues. So the data we actually collect for knob tuning it's low risk for companies, and so it's going through Amazon makes it a lot easier for us. Query tuning is obviously more complicated because there could be sensitive information. And so for that, the agent connects to the database, collects this information, and then we strip out any parameters or any constant values that are being used in queries to avoid any privacy issues. In some cases, we've been asked also to anonymize the schema, and we can do that as well, but that's less of an issue.
And by anonymization of schema, I'm assuming you mean column names and that kind
table
of thing.
Names.
Okay.
Yes, sometimes people in applications, they will. They'll make multiple copies of tables, one for each customer, and they'll put the customer name, Visa _ something in the table name. So that would be sensitive, but that is very rare. That we don't come across that very, very often.
How do you know that you need tuning?
I'll be honest. We've never seen a database that doesn't need tuning. I mean, go and answer your question, but I'm saying everybody could use some work in their life in their database, right?
No, of course, but it's if I switch from database to something else, my application frontend is fast or slow. To say whether it's fast or whether it's slow, hence needs tuning, you need to know what does normal mean, right? Kind of like, of course, everything can be tuned, but how do you know that you have a problem? What's the baseline, right? And it's not going to be the same for everybody, right?
Correct. Yes. I mean, the customers we talk with OtterTune, they range from people that don't know anything about databases. We have had people tell us they thought Amazon tuned it for them, which they obviously do not. And then we've done deployments with people, they have their full-time DBAs, and they're like, they want to do other stuff in their job. They want to do the more higher-minded things like schema design and not focus on query tuning or knob tuning. And they will let OtterTune take care of that for them. So the range is everybody has database problems. Now, people come to us sometimes, they say, I'm paying too much for Amazon, help us reduce the costs. OtterTune can help with that. Sometimes they say, these queries are running slow or getting slower over time. We need help. And then there's people that say, my database is going okay now, but we're adding new features. We know we're going to start having scaling issues. And they want something automated like OtterTune that sort of watches the progression of the database, how the application evolves. They add new features, new queries, and sort of is in growing. OtterTune's growing up with them, making sure that they're always running the system with best practices. The new version of OtterTune we're actually launching in March this year is going to have additional optimizations that are sort of aren't available in the current version. When we start making recommendations to people about their database, it will also sort of justify it and have explanation to say, OtterTune recommends this fix. And oh, by the way, 95% of the Postgres databases that look like yours also got this benefit when they applied this similar change. So that can help them instill confidence to know that that the service is making recommendations, not because Andy's the database professor or we read the textbook or whatever, because we see other workloads and we see the benefit that these things that provide to them. And I think that's the big selling point that we have for OtterTune, that yes, we can make things run faster. Yes, we can make things run cheaper, but we can give you sort of that peace of mind over time, knowing that your database is being watched and you're always running with best practices. I would say that if things are on fire, then OtterTune is not may not be the right service for that, right? Because the things we want to do are, yes, there's some benefits we can get right away, but it's the long-term maintenance of the database system itself we think this is the major selling factor of the product. So if your queries are crashing because you're running out of memory and it's just completely overloaded, you probably want to bump up your instance size before you talk to OtterTune. But OtterTune can sort of, if you sign up for OtterTune before you reach that point, we would tell you ahead of time, hey, you're going to run out of disk, you're going to run out of memory, and then maybe you want to change your instance size.
So the best time to bring OtterTune in is when things are running reasonably happy. That way you've got time to gather data and sort of see what steady state is. Is that safe to say?
Yeah, so we can detect things like, hey, you've added this table, and OtterTune will sort of watch what happens with that table over time. Or we see queries that you've never ran before, and they show up enough that we know this is something that the application is it's not a one-off query from somebody in the terminal. We know this is something you're repeatedly going to do, and we sort of watch to make sure that everything's going okay with that query over time.
And by the way, DBA, database administrator, database architect.
You found it.
If it finally showed back up. You were talking about reducing cost. Now that sounds interesting. How do you determine when is the right time to reduce costs? So I would assume in a dashboard, I would say, hey, it looks like you're running a 4x, and based on history, it looks like you could safely go down to a 2x. Is that it in general? And then what factors in, what are the magic knobs, if there are magic knobs, that would let you go from a 4 to a 2?
This is one good example of something like assumptions we made in academia turn out to be different than in the real world. I assume that instance size was probably the most important factor in terms of cost. For Postgres MySQL RDS, it's actually provision IOPS. So when we talk to customers that are maybe paying $50,000 a month for one database, maybe one or two replicas, but for one sort of logical database in AWS, the bulk of the cost is almost always provision IOPS. And what happens is people set that with the peak performance. So if I hit 20,000 IOPS at noon, I'll set myself at 20,000 IOPS. And of course, obviously, we know that database workloads follow the sleep cycles or the diurnal patterns of humans. at the workload demand at 3 a.m. is typically not the same at 2 p.m., right, during the day when everyone's working. One of the things that OtterTune can do is figure out that, okay, here's what your pattern looks like. Here's what your peak is and your minimum for IOPS. And we can automatically change that for you. Amazon lets you actually set that every 3 hours. So that actually is one of the biggest cost savings you can actually get for a lot of times in databases. And that has actually, honestly, there's nothing to do with knobs. Aurora doesn't have this. Aurora for MySQL and Postgres, you can't set provision IOPS. That one's a bit more tricky because the database system decides what's a read and write, and it goes whatever performance, it gives you whatever performance that Amazon wants to give you, and you pay for the IOPS as you use them. So that one's a bit more tricky to tune. And so to answer your original question is if I want to go down to maybe a larger instance size, if someone's using provision IOPS, that's actually the thing I would target first to save money. The next thing, the tech set of knobs would actually depend whether it's MySQL or Postgres. For Postgres, which is one we have the most experience with and see the most benefit sometimes, the auto vacuum is the one of the key factors in this, like how aggressive you are at compacting and cleaning up older versions. And of course, there's a trade-off. You can run the vacuum 24/7 or nonstop, and you'll have queries run really fast, but you're reading, writing to disk a lot more. But if you don't run it at all, then you put up a bunch of old versions, and now your queries take longer and they read more data. So it's finding out the sweet spot is actually super hard. And they actually want to change that knob on a per table basis, which we don't support just yet, but this is something we're working on in this year. Now for MySQL, it's typically how aggressive you are in flushing out the write-ahead log. Those set of knobs are the ones that make the biggest difference. Honestly, at the end of the day, it's oftentimes how much memory is available to the system as well. So if you don't have enough memory and you're reading writing from disk all the time for every query, then there's not much we can do to improve costs. You have to go to a larger instance size.
What is that conversation like? Hey, OtterTune found this. You actually need to spend more money if you want better performance. I'm sure business people don't like that conversation.
There's a couple of ways to think about it, right? On one hand, OtterTune is a paid service. Somebody did not have to hire a full-time DBA, right? The average salary of a DBA as of, I think, last year, according to the Bureau of Labor Statistics, I think it's about $100,000. And again, that's the average in the US. Obviously, East Coast, West Coast, it's a lot more. So you don't have to hire a full-time DBA. OtterTune can do a lot of these things. Or if you have a DBA, they can spend time doing other things that help the application, the developers, and not just maintaining, babysitting the software, the database system software. Alternatively, you don't have to get consultants, contractors to come fix your database. Again, but the point I would say is cost matters a lot, especially in this economy. But oftentimes people want to know that their database is running correctly. They maybe know only about their database and how to do the things to make their database run better, but they don't know all the other databases that OtterTune sees and what are the best things to tune all these other databases that we can apply that knowledge to them. And it's not just knobs, it's index tuning and it's query tuning, as I said, or honestly, cloud configuration tuning is another obvious one. If backups are turned off, we tell the people to turn them on, right? Simple things like that.
Wait, people should back up their database?
Yes. And ideally run with a replica too. And if you're using Postgres, use a proxy.
See, that's what you get for hanging around close to the end of the show here. I have to ask a non-database question. It's OtterTune. It's OTTER, like the nice furry animal that could kill you.
I'm glad you said the kill you part, because yes.
I have to ask, was this a takeoff on AutoTune? AUTO?
Yes, it's a play on words of OtterTune, and I can't take credit for this. OtterTune was started as a company, was co-founded by myself and then two of my students from Carnegie Mellon. Dana Van Aken did her PhD with me, and her PhD thesis was specifically on OtterTune. And then Bohan Zhang was a master's student that worked with us on OtterTune. So Dana's the one that came up with this. She just thought it was cute. She thought otters were cute. We did not know how murderous they are. That came out later. So there's things we can't talk about otters as through the company. But yeah, so to answer your question, it's a play on words of OtterTune.
I had to ask that because in doing research for this, went out to the site. Again, it's ottertune.com, OTTER. Yes, the nice warm animal that will kill you, tune.com. And saw all the cool otters everywhere. I was thinking, oh, this is great. And we're talking, it's like, wait, auto. Wait, we're making changes automatically. I have to admit, being able to change, this is one of the things that AWS got right ignoring Aurora, which I love Aurora, but being able to change the provisioned IOPS dynamically takes us back, Victor, into our typical world of auto-scaling, right? Because if I don't need everything all the time, now, the thing I'm sad about, but I understand why, is you can only do it, you said every 3 hours, right?
Yes.
Can you go up more and only go down? I can't remember. One of the services, like you could go up all the time you wanted to, but you had to wait for the down.
As far as I know, for the provision IOPS, you can move the slider up and down. You don't have to. You can step down.
Okay. Well, I know you could step down, but you said there was a time limit on it.
But they only let you change the value, whether it's up or down, every 3 hours.
Oh, okay. I might be thinking about EFS, which you could always bump it up all the time, but you could only bump it down like 2 or 3 times a day. So I'm probably mixing services. There's only, a few hundred services at AWS. Oh, wait, is it a few thousand now?
No, I think that AWS is close to 1,000.
I was sort of joking here. And by the way, we're actually recording this still back in 2022 prior to reInvent. So if you go back and look at reInvent in 2022.
Okay, so for our listeners, there is 1,200 then.
Exactly, by that time, yeah.
By the time you listen to this, exactly.
We've been talking about OtterTune throughout. And if people wanted to try this out, you were saying there was an academic version and a commercial version. Now, by academic, do you mean like legit academic, or is it open source?
So there is an open source version of OtterTune from the academic. It's on GitHub. I don't recommend using that because, one, it's not supported, and there's a bunch of code in there that's set up for running scientific experiments and not something that you would run this in production. So if you want to get your hands on OtterTune without having to run student code, we allow you to tune one database for free on OtterTune, right? .com right now. So you can sign up if it's Postgres and MySQL, either RDS or Aurora. You can connect for free without giving us your credit card and get tune one database for free now.
Well, Andy, thanks for hanging out with us today. If people wanted to get into contact with you, what's the best way to do that? And of course, we'll have all your information down in the show notes, but what's the best way? I'm assuming just look up your Carnegie Mellon listing and go that way?
You type in Andy Pavlo into Google. I'm on YouTube, Twitter. There's the university email address. I'm not hard to find.
No TikTok.
Not on TikTok. It's about who knows whether Twitter will still be a thing by the time this is out.
So I actually want to ask one question because I should have asked this before. Carnegie Mellon has a YouTube channel about databases. Do you own that?
Yes. Yeah. To be very clear. Yeah, this is the Carnegie Mellon Database Group YouTube channel. That is me. I put all my courses there that I teach for undergraduates and graduate level about databases. That's all on YouTube. And then we have a seminar series that we run on Mondays where we invite friends from the database community who are building database systems come talk about their particular systems. We used to do it in person before the pandemic, but then pandemic hit. We had to do something to keep the students engaged. So we just started doing it over Zoom, and we've been keeping up since then.
Interestingly enough, the reason why I was asking the question is I wasn't able to attend the Zoom, but I watched the replay for Ben Johnson's on SQLite and what he's doing there, or actually SQLite, whatever, in Lightstream. Yeah. Now, I live in the town where Richard Hipp lives, and he actually, I was running the Java user group at that time, and he came in and talked one time, and I was like, what is this guy? SQLite? What are you talking about? Or SQLite? See, what is the right way to say it? It doesn't matter. Now, once OtterTune can do SQLite changes, okay, I'm using it.
Richard Hipp is one of my favorite people in databases. He's like the most gentlest, nicest person in the world. And he's living a dream job. He's just building a database system and he puts it out public domain. And it's fantastic. So yeah, I'm a huge fan of Richard.
We've got to get him on the show.
Yes.
There's no reason because he lives in the town. I don't know him, but it's a different conversation we've talked about.
I'll send him an email.
Oh.
Yeah.
All right. Well, Andy, thanks. So we might be checking back in with you. Maybe once you get the new releases, because you were saying March is when you're going to have the new, right? Ish.
Correct.
As much as you can say about product, it's March-ish. That's your plan.
No, we have investors. It's March.
And that will be the other reason why we bring you back on, because it's always interesting to talk to people about when they do fundraising and how that really works out for people. It's always interesting to hear the story, not the dirty stories, but how it's working out and how you thought it was going to go and how it really went. So Andy, thanks for being with us today.
Hey, thanks for having me. It's fantastic.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.